The table shows the distance in feet compared to the distance in yards. So to determine if these two sets of data are proportional, we first need to determine if we have equivalent ratios. That means when we set this up, do we get the same thing each time? So we're going to determine, do we want to find yards per foot, or would we want to find feet per yard? Looking at what we're given in the table, determining how many yards in a given foot is really nice because that would be our first entry. I'm going to go with yards per foot, which means I'm going to say 1/3 yards for 1 foot. We have a 1 in the denominator, so we don't need to do anything else. We're going to move on. I'm going to say 2/3 yards for 2 feet. To compare, to see if we have equivalent ratios, I need to divide by 2. And I'll divide 2 to the top as well. That gives me a 1 on the bottom, and now I have 2/3 divided by 2. I need to make them both into fractions, so I'll put it 2/1. We don't divide fractions. Instead, we're going to keep 2/3. We're going to change division into multiplication, and we're going to flip or take the reciprocal of the second fraction, making it 1/2. I see I have a 2 on the top and a 2 on the bottom, so I'm actually going to divide by 2's. 2 divided by 2 makes a 1. 2 divided by 2 makes a 1. I'm now going to multiply. 1 times 1 is 1, and 3 times 1 is 3. This value is my numerator. It goes on top. So once again, I have 1/3 over 1. My ratios so far are equivalent. I'm going to look at my third entry now. I have 1 yard over 3 feet. Well, I can divide by 3's, and so that will give me a 1 on the bottom, and 1 divided by 3 can also be rewritten as 1/3, which is another equivalent ratio. Moving on, I will have 1 and 1/3 over 4 feet. I'm going to divide by 4 to the top and the bottom. I get a 1 in the denominator. And now that we have 1 and 1/3 divided by 4, we're going to have to change both numbers. We can't have mixed numbers. We're going to change it. 3 times 1 makes 3. Then we add the top. 3 plus 1 is a 4. The denominator stays, so 1 and 1/3 becomes 4/3. That's divided by 4, but if we're having fractions, we need to make it 4/1. When we have fractions, we stay, change, flip. So the first fraction stays the same, 4/3. Division becomes multiplication, and we flip or take the reciprocal of the second fraction, 1/4. I see there's 4's on top and bottom, and so I'm going to say 4 divided by 4 is a 1. 4 divided by 4 is a 1. And now I'm going to multiply. 1 times 1 is 1. 3 times 1 is 3. This fraction is my numerator. It will become 1/3. And this is now 1/3 over 1, just like the other 3 ratios so far. Checking the last part of our table, we have 1 and 2/3 over 5. Well, we need to make our denominator become a 1, so I'm going to divide by 5. And if I divide by 5 to the bottom, I divide by 5 to the top. So we get a 1 on the bottom. And now we have 1 and 2/3 divided by 5. 1 and 2/3, we take 3 and multiply it to 1. It's 3. plus 2 more is 5. The denominator stays, so 1 2/3 becomes 5/3. It's divided by 5 over 1. Stay, change, flip. So we keep the first fraction, we change to multiplication, and we flip or take the reciprocal of the second fraction. We have 5s on tops and bottoms, so I'm going to say 5 divided by 5 is 1. 5 divided by 5 is 1, and now I will multiply. 1 times 1 is 1. 3 times 1 is 3. This value goes into the numerator, and I get 1/3 over 1. So I have 1/3 over 1, again, 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 and again, which means, yes, we have equivalent ratios, which tells us, yes, this is a proportional relationship. Our constant of proportionality, the constant unit rate, is 1/3 over 1, also known as 1/3.